Welcome to part 2 of 6.5. So to get started, make sure you are on page 9 and we are working on 6.5 continued, complex roots and De Morveau's theorem. So I just wanted, kind of for fun, wanted to bring up a picture of De, whatever you want to say his name. So this is him, and this is his bestie, Isaac Newton. So while you're doing these problems, remember, real people discovered this amazing math that you're doing. Today we are working on complex roots. What does that word root mean? You might think of a square root, right? So like, what are the roots of let's say, of 9. Okay, well, let's think. Wouldn't they be 3 and -3? What about the roots, square roots I'm talking about in this case? Maybe I should make that clear. Square. Square roots of -9 would be 3i, -3i. So, whenever you're taking square roots, you have 2 answers, correct? If you were taking a cube root, you would have 3 answers. If you're taking a 4th root, you'd have 4 answers. So that's what we're doing today, except for it's not that simple because we are in polar world. So it's not like we can just take the square root of 9 because we are in polar complex world. So there's a couple more steps that we have to follow. And here they are. So finding the complex roots. So same system as this, but instead of it being that easy, it's going to look complicated because we're in polar world. So I'm going to give you a moment to work on the warm-up. I'm not going to go through it just for sake of time, but please go through that. And when you're done with that, let's jump into the notes. So here's how we find the complex roots. Now you'll see that this process mirrors the one we've already been doing. So what I mean by that is you should definitely be in polar form. So rewrite the problem in polar. And I made a point here just to say that the root equals the number of solutions. So that means if I'm taking a cube root, I should have 3 solutions. Next, we're going to apply De Morveau's theorem. And that's just saying whatever it is in polar, right, we're going to take a cube root. So that's going to be my exponent is the root. And that just means I take my radius to that power and I multiply the angle by that power as well. So that's what we've been doing the past couple of days. But the problem here is I have to get all of my solutions, right? So again, your root tells you how many solutions you should have. So bringing it back, right? The square root gives me 2 solutions. So to get all of your solutions, we have to add to our angle. And what we add is basically the new period. So if I have 2 solutions, that means I need 2 solutions on my unit circle. So write the first answer, and then what you add to the angle is 360 divided by n. And that sounds kind of wonky, but think about it. If I have square root, then I should have 2 answers in my unit circle. So that means I want to add 180 so that I can fit 2 solutions on my unit circle. And you'll see, we'll do an example if this is kind of not making sense yet. Your last step is to change it into standard form. So that's x plus yi, or sometimes referred to as a plus bi. That just means change it to rectangular. Now there is a way to use your calculator to do some of this, but I actually think it makes it a little bit more complicated. So for now, we're going to skip that part. But if that's something you're interested in, come see me at a later date. All right, so let's follow our steps here. Let's see this in action. All right, so step number 1 is to convert into polar. So let's look at our point here. My real component is -1. The imaginary component is √3. My first step is to sketch it to figure out what quadrant it's in. It's in quadrant 2. My next step is to solve for the radius. So that's going to be 1 squared plus √3 squared. That's going to be 3 plus 1. The square root of 4 is 2. And my angle is the tangent of theta equals y over x. So that would just be -√3, right? √3 divided by -1. So you got to get out your unit circle. You got to look in quadrant 2. And I believe it is 120 degrees. Awesome. So now my final answer for polar form would be 2 CIS 120 degrees. So first step, check. Next, we have to apply the theorem that we've been working on. So step number 2 is going to be to take this to a power. It looks like we want a cube root, so we need 3 solutions. Ooh, look, I give you a space for that. We have 3 solutions. Since I'm taking a cube root, that's taking it to the 1/3 power. You might not remember that, but remember a square root is the same thing as taking something to the 1/2 power. Cube root is the same thing as taking something to the 1/3 power. So that becomes 2 to the 1/3 CIS 120 times 1/3. So I can rewrite this as the cube root of 2. Please don't give me a decimal for that. You know I hate that. 120 divided by 3 is, why can't I do this? Oh my gosh, 120 divided by 3 is 40. Woo, brain fart. All right, so there is my, there is applying the de Moivre's theorem. That's my first solution. So yay, we have gotten our first answer. So let's write that down right away. So 3 √2 CIS of 40 degrees. Awesome. Our next step now is just to figure out what do I need to add to this to get the 2 other answers. So how we figure that out is just 360 divided by how many roots I want, which is 3. So I hope this makes sense. If I want 3 answers in my unit circle, I do 360 divided by 3. And that's going to be, why can't I do math today? What's wrong with me? 36 divided by 3 is 12. It's 120. Don't judge me. All right, so 120 is what I'm adding on to 40 degrees each time. So my next answer would be 160. And then my last answer would be 160 plus 120, 280. I hope. I'm a little rusty today. All right, so that is our answer in polar. And now it wants us to convert it into rectangular. We know how to do this, I promise. So it's just 3 √2 cosine of 40 degrees plus 3 √2 I sine of 40 degrees. So plugging that into your calculator, you will get an icky decimal for your answer. And I do want to show you it on the calculator just one time to make sure you know how to do it. Ooh, algebra, fun. All right, so how you would type that into your calculator is I use my caret key. There's some different ways you can do it, but I would just type in 2 to the power of 1/3. And I would just press enter right away. And then I'm just going to multiply that by the cosine of 40 degrees. Let's make sure we're in degree mode. We're good. So answer times cosine of 40 degrees. And my real component is going to be 0.97. So my real component is 0.97. And now I just need to do the same thing with my sine. So yes, this is really sort of annoying, but just get the process down and you'll get faster at it. I'm actually slower on my computer than I am if I'm using my calculator. So it looks like that's going to be about 0.81i. So that's the imaginary component. All right, so you do have to do this 2 more times. And I would double check that you can get these answers. But following the same process, you should get these solutions. So same process, and you should get those. So your first answer, it looks like it's in quadrant 1. And then your second answer is in quadrant 2. And then your last one is in quadrant 4. So like I said, if I'm taking cube roots, right, I want 3 total answers. Awesome. All right, I want to get you started on this next one as much as I can here. So find the complex cube roots of -8. So -8, okay, this looks kind of weird, but we got this. So my first step is to convert it into polar. So -8 is really saying -8 plus 0i. So if I graphed that, it would be -8 comma 0. So it'd be over here. And my radius is just going to be the square root of 64 plus 0, which is just 8. And my angle would be, let's see, y over x, that would be 0. So I know that my angle is 180. You also probably could have figured that out just by looking at the placement of the point. All right, so my final answer in polar is this right here. Moving on, I want to apply de Morvel's theorem. Looks like I want a cube root again, so that's going to be 1/3. So it's 8 to the 1/3 power, CIS times 80 times 1/3. 80 divided by 3, 180. 180 divided by 3 is going to be 60 degrees. 60 degrees. Okay, so we should have 60 degrees there. 8 to the 1/3 power, so that's the cube root of 8. If you don't think right away 2 times 2 times 2, you could use your calculator, but hopefully eventually you can simplify that to be this. So that is my first answer. Now I just need to figure out what do I have to add to that to get the other 2 answers. So we just do 360 divided by 3. So again, that's going to be 120. So I just add 120. So 60 plus 120 would be 180. Cut off my last one here, but 180 plus 120 would be 300. I can scroll down. There we go. Perfect. All right. So those are my answers, and now my last step is to just put them in the other form. So again, I know that this is really annoying, but it's not hard, you know, just get it done. This is on your unit circle, so you can look this up to be exact. The cosine of 6